In the previous video, I demonstrated the proof for the derivative of the sine function using the delta process, and the result we've got displayed here on the right, that the derivative with respect to x of sine u, we showed for sine x, but sine u can be done just as easily, is equal to the cosine of u times the derivative of u with respect to x. This is assuming u is a function of x, and this is just the chain rule. So you should be familiar with how this corresponds to our previous video. In this video, I'm going to show you how to show, using what we've already proved from the video before, the derivative of sine, what the derivative of cosine is. And we're going to start with f of x equal cosine x. And at this point, we're just going to say all we know is that the derivative of sine is cosine. In order to find the derivative of cosine, we need to somehow express it as a sine function. Depending on how comfortable you are with your trigonometry, you may realize that there's a clear relationship between cosine and sine. Anytime you have cosine, you can express it as sine using this rule here. So the cosine of x is equal to the sine of pi over 2 minus x. Instead of cosine x here, we can say, well, we don't know the derivative of cosine. What we know is the derivative of sine, and cosine is equivalent or equal to the sine of pi over 2 minus x. So these are the same thing, but this we can take the derivative of, because we already proved that the derivative of this is cosine. The derivative then of this function, well, we have to use the chain rule. So the derivative of sine is cosine, and the argument, or the part in the bracket, stays the same, multiplied by the derivative of the bracket. So the derivative of pi over 2 minus x is just negative 1. There's our derivative. Now, if we simplify this a little, it's not really convenient to think of the derivative this way. We can put the minus out front, but now we have cosine of pi over 2 minus x. But just like we can express cosine in terms of sine, we can say that the sine of x is also equal to the cosine of pi over 2 minus x. So cosine of pi over 2 minus x is sine of x. And so there's our derivative, and that's the rule that we showed a few videos ago, that the derivative of cosine is negative sine. Let's do a couple of examples just to practice using these two rules, the derivative of sine and the derivative of cosine. Maybe we'll add the rule here that we just showed, but we'll write it in terms of cosine of u. So the derivative with respect to x of cosine of u, what we've just shown, is equal to negative sine of u times the derivative of u, so du by dx. Okay, so there's another rule for us to remember. And let's practice it. Maybe let's say if we're given f of x is equal to the sine of, let's say, 3x squared, and we need to take the derivative, then the derivative, f prime of x, is going to equal, and we're going to use this rule, so the derivative is the cosine. We start by taking the derivative of sine, that's cosine. Keep the argument the same, so that's this part, multiplied by du by dx, which is the derivative of this, so the derivative of 3x squared is 6x. And we just usually rewrite that with the 6x in front. So there's the derivative. And one more, a question where we want to find the derivative with respect to x, the cosine of 2 minus 7x. So if we want to find that derivative, let's separate this here. This derivative, well, start derivative of cosine is negative sine. Argument stays the same. Multiplied by the derivative of the part in brackets. So the derivative of 2 is 0. The derivative of minus 7x is minus 7. So our answer, negative times negative is positive, so 7 sine of 2 minus 7x. And that's our derivative. In the next video, we'll do a similar procedure as we did here with cosine to show the derivative of the tan, cosecant, secant, and cotan functions, and do a couple of other examples.